Okay, today we have our lesson 5.2 video, which is all about polynomials. A polynomial is going to be the sum of one or more monomials, both having the nomials word in them. Mono, again, just meaning one. Poly, meaning many. So a polynomial is just a combination of one or many monomials. Now, things that a polynomial is not is any time that an expression has fractional exponents, such as x to the 1/2 or y to the 1/3. These are not polynomials. So we need to watch out for that as well. Anytime that there are square root of variables, so like the square root of x or 3 square roots of y, these are not polynomials because they have those square root of the variables inside there. Also, anytime that we have a numerator that has a negative exponent. So let's say we had x to the negative 2 over 2. This is not going to be a polynomial because of the negative exponent that is present there. Similarly, anytime the denominator, the one on bottom, has a positive exponent. So if we had 3 over b to the 4th power, this is not a polynomial because it has the positive exponent there. So now that we've kind of discussed what polynomials are and what they are not, we also need to look at the degrees of a polynomial. Now, anytime you have a polynomial, each term will probably have or should have variables to different exponents or to different powers. Now, the degree of each term is going to be just the sum of all of those powers. So then in the end, the degree of the polynomial is the highest of these degrees of each of the terms. I'll show you what I mean with our examples here. So first in our examples, we need to determine whether each expression is a polynomial or not. And if it is a polynomial, we'll state the degree. Well, in our first one, our polynomial is c to the 4th power minus 4 square root of c plus 18. Now in this case, we have 4 square roots of c, or should I say negative 4 square roots of c. And because we have the square root of a variable, we know that this one is not a polynomial. So if you came up to one on this, like on a homework problem, you would just say not a polynomial. Because it does have that, the square root of a variable inside there. Now moving on to the other one. This polynomial is negative 16 p to the 5th power plus 3/4 p squared q to the 7th power. So this one has two terms, the negative 16 p to the 5th and the 3/4 p squared q to the 7th. And it follows all of our rules. None of the fractions are exponents. There's no square roots of any variables. There is no numerator here. It's all just one piece. And so the denominator doesn't have any positive exponents, and the numerator doesn't have any negative exponents. So this one passes, and it is a polynomial. So again, on one like this, you start by saying is a polynomial, and then we need to look at the degree of each term. So we look at our first term here, the negative 16 p to the 5th. We notice that it only has the one exponent, that's 5. So this is of degree 5. When we look at our second term here, we look at our variables and they have exponent of p to the 2 and q to the 7th. So 2 plus 7 gives us a degree of 9 for this term. So the degree of the whole polynomial would just be the higher of these two, which as we can see is 9. 9 is higher than 5, so we'd say is a polynomial, and it's of degree 9. Moving along then, if we want to subtract and simplify polynomials, here we're given two trinomials. Trinomial is a polynomial that has 3 terms, so we are subtracting and simplifying these two trinomials. Anytime that we have a subtraction of a polynomial, we know that that's the same as saying adding the opposite. So if we wanted to rewrite this one, actually I'll take these away. If we wanted to rewrite this one, we would say 2a cubed plus 5a minus 7. Now again, subtraction means adding the opposite. So it'd be like adding the opposite. So adding a negative 1 times a cubed minus 3a plus 2. Because again, subtraction means adding the opposite. Now this helps us a lot here because we can see that now that we have this negative 1, we have to distribute that to each of our terms before we can add anything. So our next move then is to keep this trinomial the same, but then we need to distribute the negative to all of these. So we have, or should I say distribute the negative 1. So we have negative a cubed. Negative 1 times negative 3a gives us a positive 3a. And negative 1 times positive 2, whoops, that should be a negative 2. Now that we have our polynomials in this form, we need to look at all of the terms individually. So we have our a cubed terms, our a terms, and our constant terms. So the first ones we look at are the a cubed terms. We see that we have 2a cubed minus 1a cubed, or just minus a cubed. Next ones we look at are our 5a plus 3a. And then we look at our constants. We have negative 7 minus 2. We're not finished at this point because we still need to combine our like terms and simplify down. So 2a cubed minus 1a cubed would leave us with just 1a cubed, or we can just say a cubed. Our 5a and our 3a add together to become 8a. And our negative 7 minus 2 subtract to become negative 9. So in the end, our simplified answer is going to be a cubed plus 8a minus 9. Moving right along, multiplying and simplifying our polynomials. Anytime that we have a polynomial, in this case our trinomial, being multiplied by just a single term out front, we need to use that term and distribute it to each term on the inside of our polynomial. So to do that, in this case, our 4y squared times negative y is going to give us a negative 4y cubed, because this is y to the 1 and y to the 2, and 1 plus 2 is 3, so that is y cubed. Moving right along, negative y times positive 2y is going to leave us a negative 2y squared. Again, because this one is y to the first power, and this is y to the first. 1 plus 1 is 2. And our last piece, we have negative y times negative 3. Negative times negative is positive, so this becomes a positive 3y. Now all of these are in terms of y in different degrees, so these terms are already simplified down. So this is our final answer for the polynomial. Moving on to our second example, again we have negative 2x, which needs to be distributed to each term of this trinomial. So when we distribute it to the first one, 2x times 7x squared becomes 14x cubed. When you distribute it to our second piece here, 2x times negative 3x becomes negative 6x squared. And distributing it to our last piece, 2x plus 5x, or 2x times positive 5x becomes positive 10x. Again, each of these is in the, they're all in x, but this one is x to the first power, x to the second power, and x to the third power. So there are no like terms, so this is already simplified down.